Welcome to This Explainer. Okay, today we are diving straight into something that is quite literally reshaping how we drive. We're going to explore how rapid technological advancements are actively, right now, eliminating the absolute most stubborn pain points of EV ownership. Look, we've all heard the complaints, right? The hesitations, the worries about making the switch to electric. But the hard data, and frankly, the incredible new tech rolling out as we speak, tell a completely different story.
So let's just get right into it and address the elephant in the room. What is actually the biggest fear for EV drivers? Well, it almost always boils down to those universal anxieties of range limits and, of course, the absolute dread of getting stranded on the side of the highway with a totally dead battery. It's a massive psychological hurdle, and honestly, it holds a huge amount of potential buyers back.
Now, get this. It's pretty staggering to realize that a massive 85% of EV roadside events currently require a tow. 85%. That single statistic instantly validates those underlying driver fears we just talked about. You see, unlike a traditional gas car where, a mechanic might just fix a belt or bringing a gallon of gas right there on the shoulder, an EV breakdown is, historically speaking at least, a much more complex ordeal.
Okay, moving to Section 1, the EV charging dilemma. To really understand this paradigm shift, we have to look at the numbers behind why electric vehicle breakdowns are just so uniquely frustrating right now. Because of things like structural differences, heavier weight distribution, and really specific handling requirements, flatbed tows are actually 3 times more common for electric vehicles. 3 times! And this isn't just some minor inconvenience. It translates directly to lost time. The data shows us that EV roadside events actually take about 18%, which is roughly 12 minutes, longer to resolve than traditional gas vehicle breakdowns. That's 12 extra minutes just waiting on the side of a busy road, stressing out.
Section 2. Hyper-fast charging arrives.
All right, to solve the whole anxiety around range and charging times, we have to look at the absolute brute force charging speed hitting the global market today. We're all pretty used to fast charging taking, 30 to 40 minutes? Well, BYD's newly unveiled flash charging system, which they pair with their second-generation Blade battery, delivers an unbelievable 1.5 megawatts of output. That takes a battery from 10 to 70% in just 5 minutes. Think about that for a second. 5 minutes is exactly what you currently spend standing at a regular gas pump. The time barrier? It's officially broken. But I know what you're thinking. What about winter, right? Anyone living in a colder climate knows EVs can really struggle in freezing temps. Yet charging this new battery from 20 to 97% in extreme cold weather, and we are talking negative 30 degrees Celsius here, only takes 12 minutes. That is literally a mere 3 minutes longer than it does at room temperature. They've basically eliminated the cold weather charging penalty altogether. Meanwhile, other major players are completely rethinking the physical hardware to squeeze chargers into much tighter urban spaces. ChargePoint's new Express Solo Charger is delivering a massive 600 kilowatts to a single vehicle. And the kicker? They're doing it within an industry-leading 40% smaller footprint. Even better, that incredible power output can dynamically split across 4 different cars simultaneously if it needs to. It is quite literally maximum power in minimal space.
Which brings us to Section 3, solving grid overload.
So drawing that much raw power simultaneously across thousands of stations raises a super practical, really urgent question. How do we actually do this without completely breaking the local power grid? Well, both BYD and ChargePoint are solving this massive infrastructure hurdle by integrating intelligent energy storage directly into the stations themselves. This is the concept of flash charging. It bypasses local grid capacity limits by using high-capacity energy storage batteries right there at the station to responsibly manage these massive power bursts.
And here is exactly how that clever process works. Step 1. The station draws a really slow, steady trickle of power from the existing public grid, which crucially keeps the grid perfectly stable. Step 2. It stores that energy in its own internal high-capacity batteries. And finally, Step 3. When you plug your EV in, the station pulls from its internal batteries to deliver that ultra-fast flash charge burst to your car. You get a 5-minute charge, and you don't trigger a local blackout or force the city to dig up its power lines. It's brilliant. This infrastructure hack is such a game changer that it's allowing BYD to rapidly roll out an astonishing 20,000 flash charging stations across China by the end of 2026. Because they don't have to wait around for massive grid overhauls, they're placing a flash charger every 100 kilometers on major highways. That sheer density, combined with 5-minute charging speeds, it totally obliterates range anxiety.
Moving to Section 4, robotic charging solutions.
So if megachargers are the brute force solution,
Let's look at a much more automated approach. I want you to picture the incredible sci-fi reality operating right now in the Lingang special area of Shanghai. Meet the Charge-Go robots. These autonomous little units roam underground parking garages using laser radar, or LiDAR, to navigate and actually find your car. You just scan a QR code, and the robot plugs itself in automatically. It's super affordable, too, at just 0.51 yuan per kilowatt hour. But honestly, the most ingenious part? When they aren't charging vehicles, these robots act as peak shaving energy storage for the surrounding buildings, dynamically balancing the building's energy load. Absolutely wild.
All right, Section 5, Redefining EV Roadside Rescue.
We know EVs require way less standard maintenance than gas cars, but ironically, that actually creates a totally new set of driver behaviors that lead to trouble. The biggest issue? The no spare reality. The vast majority of electric vehicles simply do not come equipped with a spare tire. And because owners aren't going in for those regular 5,000-mile oil changes where a mechanic would typically check tire tread and pressure, they honestly just forget to check their tires at all. It's wonderfully ironic, isn't it? You're driving this highly advanced computer on wheels, but a single stray nail means you're calling in a heavy-duty tow truck.
But check this out. Interestingly, actually running out of charge only accounts for 1% of all EV roadside events. Literally just 1%. Flat tires and lockouts are vastly more common, yet that mental anxiety surrounding a dead battery is so incredibly powerful that it still heavily dictates how consumers feel about electric vehicles as a whole.
And that's exactly why roadside assistance companies like Ajero are stepping in with highly targeted safety nets to fix that customer experience. They're actually bringing ultra-fast mobile chargers directly to stranded drivers so they don't even have to be towed. They're deploying tire on-demand services to literally install replacement tires right into drivers' driveway. And they're using digital fix remote solutions to solve software glitches over the phone, getting people back on the road almost instantly.
Seeing this incredible wave of hardware, smart robotics, and specialized rescue tech, we're really forced to look at the future of driving differently. As these final hurdles disappear, as charging matches the speed of a gas pump, as grid constraints are smartly bypassed, and as automated robots and modernized roadside networks cover your absolute worst-case scenarios, what is actually holding you back from making the switch? The infrastructure of tomorrow is practically already here today. Thanks for joining me for this explainer, and I hope it helped you see the road ahead just a little more clearly. See you next time.